Today we're looking at LeetCode question 203, remove linked list element. Given the head of a linked list and an integer val, remove all the nodes of the linked list that has node.val equal to val and return the new head. Example where val is equal to 6. We've got nodes 1, 2, 6, 3, 4, 5, 6 and null. You can see below that the two 6s have been removed, leaving 1, 2, 3, 4, 5 and then null. The approach that we're going to be taking is called the dummy pointer technique. It has a time complexity of O of n and a space complexity of O of 1, and it's the optimal solution to this problem. Now let's walk through an example. We've got nodes 1, 2, 6, 3, 4, 5, 6, and then the end is null. The val that we're looking for is 6. Step 1 will create a dummy node and a current pointer. The dummy node is going to be a new list node with a value 0 pointing to the head, and the current is going to be pointing at the new node. Step 2. We need to loop over each node while current.next is not null, applying the following logic. If current.next.val equals val, well, it does not, because it equals 1. And we need to update current equal to current.next. So let's point this pointer to the 1. And we'll go back up and we'll check if current.next.val is equal to val. So we'll update that, pointing at the 2. 2 does not equal 6, so let's move the current. Set current equal to current.next. And we'll go back up and we'll check if current.next.val equals val. So we can see that current.next.val is equal to 6, val is 6. So current.next should be equal to current.next.next. So we can see that that's a 3. We then check if current.next.val equals val. It does not, because it's 3, so we'll set current equal to current.next. So we'll put current pointing at the 3. And then we'll check if current.next.val is equal to val. Well, current.next.val is equal to 4. So we then set current equal to current.next. So let's update the pointer to point at 4. Then we check if current.next.val is equal to val. Well, current.next.val is equal to 5, so that's not true. So we set current equal to current.next. Move the current to point at the 5. And then finally we check if current.next.val equals val. Well, current.next.val is 6 and val is 6, so that's true. So we set current.next equal to current.next.next. And that's going to be null. So that's going to break us out of our while loop, because current.next is now null, which is not true. So we'll break the loop. In step 3, we'll return dummy.next. Thank you very much for watching the video. It's as easy as that. Why not pause the video and try to implement a solution yourself? If not, stay tuned for my solution next. So let's look at LeetCode Problem 203, remove linked list element. We're going to solve the problem today using Java. Cool, so given the head of a linked list and an integer val, remove all of the nodes of the linked list that has node.val equal to the val and return the new head. So if we look at example 1 here, where you've got 1, 2, 6, 3, 4, 5 and 6. The val has been provided here, which is equal to 6. So basically we want to return 1, 2, 3, 4 and 5, which we can see down here. Example 2, we are given we're given head and val is 1. Head doesn't have anything in it, so the output is going to return an empty array, or null it should return. And in example 3, we can see that we've got 7, 7, 7, 7, val is equal to 7. So again, everything needs to be removed, so we would then just return head, which is equal to null. So based on these three examples, I think there's sort of three clear three clear edge cases to consider when solving this problem. The first one is where we're going to be provided a linked list that the head is pointed at null, basically an empty linked list. The second one is where we are provided a linked list where every node has a value equal to the val that we want to remove, which in that scenario we need to obviously return just where head is pointing at null, an empty linked list. And another scenario would be where we have a linked list where none of the values equal val, so we're basically just going to return the linked list that we were given. So the approach that we're going to take today is called the dummy node technique, and it's where you create a dummy node, and this allows you to then process all of the subsequent nodes in the same way. So it really helps a lot with the edge cases. So let's get into it. So we'll create a list node equal to dummy. List node called dummy equals new list node. We'll set the value equal to 0, that's not important, and we'll have the next item to be head, and then we want a current pointer which will set current is going to be a list node, and we'll set that equal to dummy. Then we want to loop over every node in the linked list, so while current.next doesn't equal null, then let's check if current.next equals val. If it does equal val, then we want to set current.next equal to current.next. So that's basically going to jump over the item that the node that we want to remove. So that's going to then remove it from the linked list. Else, very good typing. Else, we want to set current equal to current.next, and then finally, once we've processed all of the nodes, we just want to return dummy.next, which is the new head. And let's see if that runs. It does not. Current.next equals val. Current.next.val is what I wanted to point at. We'll try that again. Cool, so that's been accepted. Let's submit it, see if it passes the tests, which it does. And according to this thing, apparently it beats 93.61% in terms of runtime, and it beats 55.37% in terms of memory. So the runtime complexity is O of n, because obviously we have to loop over every item in the array, in the linked list, and the space complexity is O of 1 constant. It doesn't change with the size of the linked list. Well, thank you very much for watching the video. If you like it, please click like. If you would like to see more videos, then click subscribe and the notification icon. And if you've got any feedback or you'd like to see any other videos, then please leave the comments below. Thank you very much for watching, and good luck with your interviews.